Okay, so we're talking about triangle similarity. So we've been talking about the ratios and all sorts of proportions with our similar triangles, and now we're going to have these actual theorems. Okay, so similar to our congruence theorems where we had side, angle, side, angle, side, side, etc. Here we have these theorems that talk about similarity. So if we have triangles like this, and this here is that little tilde that we've been talking about, the little squiggly that says that these are similar. Now, you can see that angle C is congruent to angle F, and angle A is congruent to angle D. If we have two angles, then these angles are going to be congruent as well. So what we're going to be able to find is that angle B will be congruent to angle E, which will mean that the triangles will be similar. So what we can say is if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay. By our definition of similarity, all of our angles are going to be congruent. So what you have here is angles congruent. Okay. We call this one AA, not to be, I guess, confused with the other AA that we talk about. We're talking about AA in math here. So what we have here is all of our angles are congruent, therefore our sides are going to be similar, so they're going to be some sort of proportion. The other one we're going to talk about today is side similarity. So this one is just like our congruence one, side, when all of our sides are congruent, the triangles are congruent. Here you have all the sides are similar, so they are going to be able to create some sort of proportion. So what we're going to be able to say is that AB over DE is equal to, and we're writing these proportions again, is equal to BC over EF. Okay, so what we're able to say is we're able to match this side, AB and DE, and then BC and EF, and those are going to be, is this going to be similar? Yes, we're going to be able to say that this is okay by the proportion. So if three sides are proportional to another three sides, then the triangles are similar. Okay, they're okay by the proportion standards. Okay, so let's look at what some examples of this are going to look like. You're going to need to be able to figure out what similarity theorem we're talking about. So this first one is talking about AA. This is angle. We just need two angles. Explain how you know the triangles are similar and write a similarity statement. And this is that using the squiggly that we have. So I can see here that these two triangles here, I have 92, so I have angle Q is congruent to angle T. Okay, and then the other angles I have is angle R. Okay, the measure of angle R is 49, and the measure of angle V is 39. Okay, these are not congruent. The measure of angle R is not congruent to, or angle V. I'll make this M here. Okay, so these are not the triangle theorem. None. These are not similar. Okay, and if I was talking about the triangle statement here, I would say that they're not similar in this case here. Okay, now if this was, so the triangle statement that we would have is maybe triangle QRS is similar, but it's not similar to triangle, and I want to keep the same. Q matches with T, R should match with V, but it doesn't. QVS. So they're not similar. Okay. If I had maybe this here, V was 49 degrees instead, then I would be able to say that these are similar. Then I would be able to say that angle R was congruent to angle S, and that would make the triangle theorem AA here. So what we are trying to do is figure out, are they similar or not, and according to what we're given here, these are not going to be similar triangles. In the second example, we've got side, side, side. Oops. Explain how we know that they're similar. We need to check for some proportions on this. So if I'm looking at CA, I want to match that with one of the sides here. We'll say that it matches with PM. Is that going to be equal to the proportion that I have? And I'm not going to choose these same. Remember, these are going to be isosceles triangles, so those are going to be the same. I want to check to make sure these bottom ones are going to be the same, PN, okay, which means that I have 12 over 15 equal to 8 over 10. So are these going to be the same? I need to cross multiply here. I end up with 12 times 10. Is this equal to 8 times 15? So 12 times 10 gives me 120. Is this equal to 8 times 15? Which 8 it is. Okay, so since I can show this proportion, I have the theorem as SSS, side, 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 and I want to make this statement here. I'm going to call this triangle ABC, similar to, actually, you know what, I'll call it CAB, how I see it here. CAB is similar to triangle, and we'll start at the top. I did CAB, so I need to go from the bottom, PMN, triangle PMN. Okay, so this is what all of your examples are going to look like going forward, so use these to answer the questions. There's only a couple.